Hello everybody, and welcome back to another Big Ideas Algebra 2 lesson. Today, 6.5, Properties of Logarithms. These notes are very short, but there's a lot to take in here. So let's jump into it. Much like exponents have properties, logarithms also have properties. So like if I gave you x to the 7th times x to the 5th, we know that one of the properties of exponents is you can add them up when they're being multiplied. This would be x to the 12th. In much a similar way, we have properties of logarithms. So the first type of property of logarithms is called the product property. And the product property works like this. Let's say for a second that we have the following logarithm. Let's say we have log base, let's make it log base 5 of 7x. Now I don't know about you, but I have no idea how we could even think about evaluating this. However, the product property gives us a little bit of a hint that might help us simplify it. The product property says that if you have a logarithm with any base, so that includes natural logs, with two numbers that are being multiplied as the argument, remember the argument is what comes after the log, then we can rewrite it as two different logs being added. Log base b of m plus log base b of n. So if I have log base 5 of 7x, we can rewrite this as log base 5 of 7 plus log base 5 of x. We just split up the argument. Right now, this doesn't look too useful, right? However, it actually can be quite useful with some problem types. Let me give you a brief example here. Let's say I'm trying to find log base 3 of, let's do log base 3 of 30. In other words, this is asking us 3 to what power equals 30. I'm going to be entirely honest with you. I have no idea what power 3 should go to get 30. It's probably going to be a little bit bigger than 3, because 3 cubed is 27, but I have no idea. Well, we can actually break up 30 into two numbers being multiplied. We can break it up into any two numbers we want. Maybe we break it up into 1 times 30. Maybe we break it up into 2 times 15. I'm going to break it up into log base 3 of 3 times 10. And you'll see why in a moment. That means I can split it up as log base 3 of 3 plus log base 3 of 10. But wait a minute. Log base 3 of 3, wouldn't the base here and the base of our argument cancel out? We learned that a logarithm can cancel out if the bases are the same. All that would be left over is whatever power is on the 3. In this case, it's just 3 to the first. So that means we can actually cancel out these, and we'd just be left with 1 plus log base 3 of 10. Still, we would have to know log base 3 of 10, but it gets us a little bit closer to an answer we can actually use. So that's the product property. The quotient property is very, very similar. In fact, the quotient property is basically the same thing. It's just instead of m and n being multiplied, it's what you use if m and n are being divided. And the rule is, you can simplify it or expand it as log base b of m minus log base b of n. Numerator first, then denominator. So if I'm trying to figure out how to simplify log base 7 of, let's do x over 7, we can rewrite this as log base 7 of x minus log base 7 of 7, and would you look at that, we can use our rule again. When you have the same base in the argument and as the base, they cancel, leaving you with just 1. This is the same as log base 7 of x minus 1. There is one more rule that we have here. It's called the power property. The power property kind of works like the power of a power property with exponents. It says, if you ever have a power in your logarithms argument, so like this is m to the n power, the n can just go in front, and this is an incredibly useful tool for us. Remember back during our quiz, I would give you a problem like this. Let's do log base 4 of 16 to the 3x power. And we learned for our quiz that the way to do this is to turn 16 into 4 to the something power. In this case, we can just turn this into log base 4 of 16 is just 4 squared to the 3x power. From here, we can apply the power of a power property and multiply our exponents. That's the same as log base 4 of 4 to the 6x power. And when we cancel out our bases, we end up with just 6x as our answer. Cool. It turns out there's an easier way to do it, and it's using this power of a power property. Or sorry, just the power property of logarithms. If we have a logarithm with base b, and the argument is m to the n power, we can write it as taking the n and putting it in front. This would be n log base b of m, and it might be a little bit easier to simplify. Let me give you a similar example. Let's take this one from before and rewrite it down here. So log base 4 of 16 to the 3x power. Well, according to this power property, we can just take the 3x and move it to the front. This would be 3x times log base 4 of 16. Now we can just look at log base 4 of 16 and see if we can evaluate it. So remember that log base 4 of 16 is the same as asking 4 to the what power equals 16? Well, we know that 4 squared is 16. So log base 4 of 16 just equals 2. That means we bring down our 3x, but instead of log base 4 of 16, that just equals 2. Our answer is just 3x times 2, which we know is 6x. The same answer we got using the other method. This gives us a much nicer way of dealing with these exponents. Just put them in front of the problem and deal with them when you're done. That seems like it's much easier than splitting up 16. With these three powers combined, we can actually do a couple of examples. So, what I'd like us to do first is I'd like us to take a look at A here. We've got the natural log of 5x to the 7th over y. Remember that natural logs and logarithms are treated the same way, so we can use all these properties. The way we look at it is, we've got a numerator, we've got a denominator, well, we've got a quotient property that we can use. Anytime we have a fraction, we can split it up. So let's split this up into the natural log of 5x to the 7th minus the natural log of y. Then we look at this natural log and realize oh, this is just 5 times x to the 7th. So we can split that up as well. We can split that up into the natural log of 5 plus the natural log of x to the 7th power minus the natural log of y. Now, are there any other rules that we can use here? We absolutely can. See how in this middle term we have x to the 7th power? The power property tells us to move that 7 in front of the logarithm. So our final answer is the natural log of 5 plus 7 times the natural log of x minus the natural log of y. And we are done. This is the expanded form of what we saw before. What I'd like you to try to do is I'd like you to try out C here. Try to expand out C as much as you can, and come back in a minute to check your work. How'd you do? If we take a look at C, we have log base 6 of 3x to the 4th. Well, that's just 3 times x to the 4th. So we can write it as log base 6 of 3 plus log base 6 of x to the 4th. And what do we do with exponents? We put them in the very front. So this is log base 6 of 3 plus 4 times log base 6 of x. Done. That's our expanded form. You will be asked to expand these on the test, but it's not going to be the thing you see the most often. What you're actually going to be seeing is a lot more condensing of logarithms, taking multiple logarithms and putting them together. Before we jump into these, I want to address the elephant in the room. No, we don't need a second log here. That was absolutely a typo in the notes. So cross off anytime you see log log or ln, just cross off one of those logarithms. So same with problem D, it's double printed. Like so. So what we're really dealing with is log of 9 plus 3 log of 2 minus log of 3. Well, to do this, all we need to do is use these rules in reverse. So my recommendation is always to start with your power properties. If you see any numbers in front of the logarithms, write them as the exponent of your argument. So we see right here in the middle that we've got 3 log of 2. We can rewrite 3 log of 2 as log of 2 cubed. But wait a second. 2 cubed is just a number, right? What number is that? That's the same as log of 8. So if we rewrite this, we get log of 9 plus log of 8 minus log of 3. We're on a good track. Now we see a bunch of stuff being added and a bunch of stuff being subtracted. My recommendation? Deal with your products first, then deal with your quotients. So, here we have log of 9 plus log of 8. Remember that these are common logarithms. We imagine their base is 10. So all we need to do is combine them into a product. Log of 9 plus log of 8 is log of 9 times 8 minus log of 3. And what is 9 times 8? That's 72. So this is log 72 minus log of 3. And how can we combine these two logarithms if they're being subtracted? Well, if they're being subtracted, we can write them as a quotient. Basically, put the first one as your numerator, and the second one as your denominator. So log 72 minus log 3 is the same as log 72 over 3. And is 72 divisible by 3? I certainly think it is. 72 divided by 3 gives us 24. So this long written sentence, log of 9 plus 3 log of 2 minus log of 3 is the same as log of 24. I'd like you to pause the video here and try to see if you can do D on your own. It's very similar to B. Hopefully we've had a chance to try out D. Let's take a look. So once again, we always want to get rid of our powers first. So 3 natural log of 3 can be written as the natural log of 3 to the third power, which we know is just 27. So we can rewrite our statement here as natural log of 4 plus natural log of 27 minus the natural log of 12. Now we see that we have a product here, product property. Whenever we see two things being added, we can write them as a product. So ln of 4 plus ln of 27 is the same as ln of 4 times 27, minus the ln of 12 at the end, of course. And what's 4 times 27? This is the same as the natural log of 108 minus the natural log of 12. All we need to do now is use our quotient property. Whenever you have two terms being subtracted, put the first one on top, put the second one on bottom. So this is the same as the natural log of 108 over 12. And what is 108 divided by 12? 9. This entire thing is just log of natural log of 9. Very nice. The last thing we're going to take a look at today is something called a change of base formula. With our modern calculators, change of base is not something that's as important, but is still pretty critical. Let me give you an example. Let's say I was trying to evaluate log base 3 of 8. In my graphing calculator, I would have to press math, scroll all the way down to log base, put in a 3, put in an 8, and get my answer. However, it'd be easier if there was a way to turn this into just a regular log, so we can just use our log button, or our ln button. The change of base formula helps us with that. It says, if you have a logarithm with a base of c and an argument of a, you can rewrite this with any base you want. We'll call it b, as long as the argument is on top of the fraction and your denominator has the same base with your c on the bottom. This is the change of base formula. So if I really wanted to, I could transform log 3 or log base 3 of 8 into anything I wanted. Let's say I didn't want log base 3 of 8. Let's say I wanted this to have a base of 8, so I could at least simplify the 8 here. Well, the formula says you put the first one on top, you put the second one on bottom, you put your base on bottom, I should say, and now we can put whatever base we want in here. If I make it 8, for instance, we see that log base 8 of 8 cancels out to just make 1, and log base 8 of 3 would be our denominator. So what we've just done is we have just changed it from being 3 to the something power equals 8. We've just changed it into 1 over 8 to the something power equals 3. What we are going to ask you to do is to use this change of base formula to change into a common logarithm. As a reminder, common log is when you don't have a base, you just assume the base is 10, and to transform these using natural logarithms. I'll show you the first one, and I'll see if you can do the others on your own. So, to change this into common logarithms, all we need to do is split it up. We have our argument on top, we have our base on the bottom, and since we want the base to be 10, or otherwise we don't put it there, we just leave it. Our answer is just log of 8 over log of 3. So remember what we got for our log base 3 of 8? We got 1.8927. Well, now I can just do log of 8 over log of 3, and we get the same answer. So it's a shorter way of dealing with this. It's a nicer way of dealing with this. And it's a way we deal with it, especially in real life a little more often, where things like the Richter scale or the Scoville units actually do use the common logarithm base. Try out the rest of these, pause the video, and come back to check your work. How'd you do? For B, we should have gotten log of 30 over log of 12, since we wanted it in common logarithm form. For C, we want it as a natural logarithm. Well, that's no problem. That's just ln of 24 over ln of 6. And for D, we wanted log base 5 of 8 turned into natural logs. That's just ln of 8 over ln of 5. Done! Thank you so much, everybody. This concludes our notes for today. I hope you have a fantastic rest of your day. Take care.